trying to capture fabrication underway or near completion here.
Stenciling and holiday testing, but it's close to complete.
What we're looking at is one of two ballast frames, and what these are used for, we have our two freestanding risers, and from the seafloor they have a foundation consists of a suction pile that will be bedded in the seafloor. These ballast frames will sit over those piles, one per pile, and what they provide is a platform to put additional clump weights. We'll put on the order of 8 clump weights on each of these ballast frames, 2 on each side. Each clump weight about 30 tons each, and that provides enough resistance to uplift of the risers. You can see at each corner of the ballast frame we have a lifting lug and a shackle, so we'll be using those lifting points to lower the ballast frame to the seafloor. This is a permanent storage and installation reel for a subsea control umbilical. This is a relatively large reel. It's about 11.4 meters in diameter, and they're going through a process right now of repairing some welds, replacing some material, and then finally they'll be recoating, repainting the whole umbilical reel, so it'll be good for a 25-year life. The way it works here, this reel would be actually installed on another piece of machinery we have right now called a powered reel drive, and that will basically unspool the umbilical to another piece of equipment on the installation vessel called a vertical lay system or horizontal lay system, which provides means to, in a controlled manner, lower the umbilical under a controlled tension without crushing or squeezing the umbilical too much to get it into its final deployed condition. Here you can see some of the work in progress on the repairs, weld repairs that are being done. These welds weld these thin cover plates to the spokes of the wheel. And they typically use what they call a stitch weld, which is where they weld for a few inches, leave a gap, weld a few inches. We've asked Technip and their subcontractor to do is have continuous welds where they have this stitch welding before.
Well, what we have here are the flexible friction clamps. These will be deployed in water depths of 500 to 2,000 feet, where we use a lazy wave riser configuration. The main purpose of these clamps is to anchor the flexible pipe to the seabed floor, and that'll be done by means of a concrete mattress. These clamps are designed to grip the flexible without letting it slip while not damaging it, which is why we have a long surface or a long contact area of the clamp. They mainly come into operation under a high current condition where we see large movements of the lazy wave risers. These are used to apply tension on those lazy wave risers to keep them in place so they don't slide around too much on the seabed floor. These clamps are unique in design because of their compact nature. We wanted to minimize size and minimize installation time. So to do that, we had to make them smaller and put the bolts and studs closer together. In doing so, it's made some really tricky fabrication, but we've managed to overcome those challenges. Each hole that you see here will have a very long stud that goes from the top half shell to the bottom half shell, and we'll thread some nuts onto each of those studs, and we'll use hydraulic tensioners to compress both halves together. It's that compression force that holds the flexible tight.
We're looking at these two vertical cradles. They're the installation aids for the buoyancy cans. So this buoyancy can that's fabricated in Technip offshore Finland is positioned vertically at the top of these vertical cradles and bolted on and transported offshore with the help of these vertical cradles. So as you see, we've fitted up all of the main structure, and now we're welding it out. We're about 60% complete on both of them approximately. Next step will be to NDE all the welds and blast the structure and paint it. Then we have the drilling of the holes that matches the pattern of the buoyancy can, so the buoyancy can be placed there and positioned. These are provided as basically for the offshore deployment, so they're not part of the main structure of the riser. They're to aid the deployment of the equipment in case of the emergency. Yeah, they put this on the vessel, and then we put the buoyancy can vertically on top, bolt it up, and then we can sail out with the vertical, the buoyancy vertical, so we can then deploy it